All right, on this very icy day, I'm gonna make the video first, solving first. Then I'm gonna hope for the best because my iPad doesn't have very much juice, and I apparently left my charger at school. And yes, I am a person who does not have an iPad charger at home somehow. So let's get to it. I'm doing this one because I think it'll go a little bit faster and I can get it posted for you. So, to sign, I'm gonna move that thing over. And then I'm going to divide by 2, and this one's pretty straightforward. So this is a good, like, easing back into it. Then what I need to do is go to the unit circle and find the places where that happens using this interval. So in this case, the x, theta, whatever they want to call it, the places where the sign, aka y value, have a value of root 3 over 2 are at pi thirds and 2 pi thirds. The key is online. But just so you can kind of see where it came from. Now this one I have to be careful because this has the 2x. So that's that multiple angles business. That was 5.3b, day 2. So I take the regular period of cosine and divide it by what that number is. And so that's telling me that they're going to repeat every pi. So later on, I'm going to have to add that to my original answers. Also, if I get a 2 here, I usually think I'm going to get 4 answers total. So those are just good things to think about and notice, because otherwise it's easy to just ignore that part. I'm going to start by dividing that root 2 to the other side. And then I get 1 over root 2, but we're going to be honors pre-calc kids, and we're going to go ahead and rationalize that. So what I do at this point is I go to the unit circle and I figure out where is the cosine going to have this value of root 2 over 2. But that's not my final answers. It's what 2x will equal because of what I've got going on here. So there's going to be 2 options, and so I'm going to find out what they are. So on the unit circle, the first place that cosine is root 2 over 2 is at pi fourths, and then the second place is at 7 pi fourths. Okay, so to get that to be just plain x, I need to divide it by 2 or multiply by a half. So my first answers to this are pi eighths, and then doing the same thing here. My first answer down here is 7 pi eighths. Okay, but that's where this comes in. We now have to add pi. But since it requires a common denominator, I'm going to think of it as 8 pi eighths, which you'll see in the notes or the key. And so I'm going to go ahead and add 8 to my 1 pi and get 9 pi eighths. Now, the reason I don't add it again is if I did, if I added another 8 pi eighths, I'd get 17 pi eighths, but that is more than twice around the circle because 2 pi with an 8 on the bottom would be 16 pi eighths. So that's too big. So I'm only getting those 2 answers. Down here, I'm going to do the same to my 7 pi eighths and add that 8 pi eighths, which is really just the pi. And so I'm going to end up with 15 pi eighths. And again, the reason I can't go beyond that is I get outside of my my range for answers. It goes beyond 2 pi. And I have the 4 answers that I was expecting. Same thing's happening here in that I have multiple angles. I don't have to do anything actually. So I just start by looking for where the sign is a half, and that's what 3x will equal. And there's 2 places on the unit circle that the sign is going to be 1/2. One of them is going to be at pi sixth, and the other one is going to be at 5 pi sixth. But just like in the previous problem, I then divide this by 3. So my first answer is pi 18ths. And if I divide this one by 3 to get rid of this 3, my second answer is 5 pi 18ths. So my answers to this problem, and I'm expecting 6 of them because it's double what I see, I'm expecting that, excuse me, each of these is going to apparently give me 3 more answers, or 2 more answers, so 3 total. So now that I know the bottoms are 18, I go over here and I think, okay, take the normal period, divide it by that number with x, and that's going to give me the space. But since I have 18 on the bottom, I'm going to get a common denominator by multiplying this by 6 and this as well. So this is going to be what I'm adding to these numbers. So if I add a 12 here, I end up at 13. Now, again, keeping in mind that you have to be under 2 pi, think about what 2 pi will be. With an 18 on the bottom, it'll be a 36 on top. So you can't go beyond that. If I add my 12 to the 13, I'm at 25 pi. But if I added 12 again, I'll be at 37, which is too big. On the bottom, when I add this spacing to it, that's going to give me 17 pi over 18. When I add 12 again, I get 29 pi over 18, but I don't add it again because I'll go beyond the limits of that 2 pi range that I'm given for answers. So here, this one looks so confusing, but I can't do a problem with two different variables. And so what I'm going to do is I'm going to rewrite this part as 1 over cosine. And then these need a common denominator to be subtracted, so I'm thinking of them as both over cosine. This was already over cosine and stays 1, but over on this part, I'm going to need to multiply the bottom by cosine, and therefore I'll have to multiply the top by a cosine to adjust it. So the top left becomes 2 cosine squared x. In order for a fraction to equal 0, the top has to equal 0 because the bottom can't. So I need 2 cosine squared, excuse me, not surprisingly, I'm sick and choking. So I'm just going to go ahead and add that 1 over, divide by 2, and then square root. Please remember that you got to introduce that plus minus when you do a square root into the problem. So at this point, the cosine of x is going to be plus or minus, and this is going to turn into root 2 over 2 when I rationalize that. So hopefully everybody's sort of okay-ish with that. So I go to the unit circle. This is not multiple angles. My x's up in the problem are just singular. It's not 2x or 3x. So I'm just going to get whatever I get on the unit circle, but I do get 4 answers simply because of that plus minus. So if you forgot the plus minus, you're going to be missing 2 out of your 4 answers. And I don't believe like 50% is what you're going for. So here are my answers to that one. All right. Taking a look here, I see a square. I'm going to go ahead and work towards square rooting to get rid of that by adding the 1 over. Then I'm going to divide by that 4. Now it's time to square root plus minus. This is going to turn into just sine. And then if you use your thinker, this is like the square root of 1 over the square root of 4. So I just get a half. And again, there's no multiple angle in here. My x is just singular, like it's not 2 or 3x. So I'm simply going to the unit circle and seeing where that's true. And that is true at these values. All right, so then that is what I'm looking for. So on the quiz, remember there's only 5 questions. There's going to be a mix of the individual x's, these that have the multiple x's, factoring, square rooting, you know, that kind of, it's going to be a mix, and you only have 5 questions, so kind of one of each thing probably. So speaking of factoring, if you want to like think of this as something we would have seen in Algebra 1, to factor it, maybe that makes it easier, and you think, okay, what would I need to do to factor it? Well, the only way to get 1s is 1. I'll need a 2a times a, and from the outside inside combination of my foiling, I need the middle to be negative. So I actually need this negative 2a on the outside to be bigger than the positive 1a on the inside. It's the same exact layout, except that instead of a, I have cosines. So I end up with 2 cosine x plus 1, and then cosine x minus 1 as my other factor. So then, like always, we're looking to see what makes this factor equal 0 and what would make this factor equal 0. This one's pretty straightforward. The cosine would have to be 1. I go to the unit circle, and the cosine is 1 at 0, and because my instructions have the 0 included and the 2 pi not included, I have to write it as a 0. So that's going to be one of my answers. And that's the only place the cosine is a positive 1. Here, I'm going to proceed by moving that 1 over and dividing by 2. And then I go to the unit circle and I look for any places where the cosine or x value is negative 1/2. And I'm finding 2 pi thirds and 4 pi thirds to add to my answer list. And so that is my solution set for 21. How's that 21? I do not, oh, because we started at 16. Why? No idea. All right, all solutions. This is that general solution thing. Excuse me, and it does ask you this a couple times on the test to make sure you know that. This is where I have to consider all the general solutions that go forever and ever in both directions, the coterminals basically. So whatever values I get, I'm going to be taking those values and adding or subtracting 2 pi n unless it's tangent. Because with tangent, I would use a 1 pi. I'm just sitting here thinking that none of these are cosecant or anything. So that is problematic because there are cosecants on the quiz, you know, like cosecant or secant. So I might go sneak back and see if I can find one quick on another worksheet. The solving is no different. I still just move that over and I divide by 2 and I go to my unit circle and I find that the cosine is going to be negative 1/2 at 2 pi thirds and also at 4 pi thirds. But to each of those, I'm going to be adding, my laundry machine is singing at us if you can hear it. I'm going to be adding that coterminal aspect, so it's giving the general solution, like all possible numbers that exist in the whole entire world, which is usually a lot. All right. Move that over. Divide. And square root plus or minus. So I end up with sine x. And over here, I can't square root the 3, so it stays that, but the 4 turns into a 2. So I go to the unit circle. Obviously, that has a couple of places that happens. And actually, because it's plus or minus, I'm going to have 4 places. So I'm going to have pi thirds. I'm going to have 5 pi thirds. I'm going to have 2 pi thirds. And I'm going to have 4 pi thirds. Those are all the places that the sign will be either positive or negative. And then in each case, I'm adding 2 pi n, adding or subtracting, to account for the fact that I could use any coterminal version of that. That's my general solution. Goes on forever and ever and ever, not limited to one trip around the circle. And then this one I think is pretty straightforward as well. I'm going to take that 1 away. I'm going to divide by root 2, and I'm going to end up with, after rationalizing, negative root 2 over 2. So that only occurs in 2 places, at 3 pi fourths and at 5 pi fourths. And then I would just add that general solution aspect that they're looking for and call it a day. Stick with me here a second. If I can just find... I'm just trying to find something that has notes. I'm just looking to see if I can find a solving thing that has secants, cosecants, cotangents on it. I don't see it yet. How's that possible? Well, I know we did them, so I feel really confused about that. I guess I'll find some when we're in class together quick, or I will find some later and put them on here. But you guys would just solve the problem, and then if it's like a cosecant, you would flip it over. So say you get cosecant, here, let's just make a note quick. If you get to a point after doing your work and you're like, oh, okay, I have cosecant x equals 2. You can't do that. So you flip this over, make it sine, and you flip this over and make it 1/2, and then you can go to the unit circle. So that's pretty terrible example, but just that's the only difference is that at the very, very last stage, you would have to flip over your cosecant, make it a sine. If you have a secant problem, you'll flip it over and make it a cosine. And then whatever is equal to over here has to flip as well. I think you guys know how to do that. I think you're awesome at solving. So hopefully that'll help you feel prepared for that. And I will try to use the last of my iPad juice to make a video for the graphing because I think that part's going to be a little trickier. See you soon.